Hello, students.
Hello, sir.
Yeah. Good evening.
Yes, sir.
This is extreme scientifics. So we are studying chemistry today. So the topic is on elements, symbols, valency, and compound. Again,
Elements, symbols, valency, and compounds.
again,
Elements, symbols, valency, and compounds.
elements, symbols, valency, and compound. Again,
Elements, symbols, valency, and compounds.
again.
Elements, symbols, valency, and compounds.
That's good. What is an element? If you notice in the scheme of work that I gave you, I didn't write element there. Just go straight to the atom. But before we talk about the atom, we first deal with the elements. Are you understand what I'm saying?
Yes.
You deal with what?
Elements.
You have to know the elements, you have to study this atom. Are you understand what I'm saying? So you first talk about the element before you talk about the atom. Before you go inside of the elements. Are you understanding me? So, number one, what is elements? An element is a substance which cannot be split into simpler substance by any chemical means. What does it mean? Okay, first read it before I explain what it is.
An element is a substance which cannot be split into simpler substance by any chemical means.
Again,
An element is a substance which cannot be split into simpler substance by any chemical means.
again,
An element is a substance which cannot be split into simpler substance by any chemical means.
good. An element is a substance which cannot be split into simpler substances by any chemical means. What does it mean? When we talk about any chemical means or ordinary chemical means, you can't split an element. You can't do what?
Split an element.
No. You can't split an element by ordinary chemical means. But there's another way to split an element. That's called radioactivity. What do I call it?
Radioactivity.
But that one, it has to do with what is called nucleus, nuclei, half-life, all these stuff. So radioactive. So under it we study about nuclear fusion and what? Fission. I've been telling this for some time now. But on a norm, under any chemical means, you cannot split an element. You can't do what?
Split an element.
Yes. Even with high heat energy, you can't split an element. You can't split an element. If you melt an element under a strong heat, it will still be the same. The only way you can split an element is if that element is radioactive. What does it call it?
Radioactive.
So when we begin to do with nitrogen and actinide series, all these uranium, polonium, plutonium, einsteinium, you know what I'm saying? So Californium. So we're talking about splitting an element under radioactivity. But on a norm, you can't split an element using ordinary chemical reaction. I understand what I'm saying. So if they bring an element down, they say you should split it. If that element is not radioactive, you can't split it. You can't split it to other substances. But you can get compound of an element, molecule of an element. What does it mean? That is, sodium can react with chlorine to form a what? Sodium chloride. That is a molecule. You understand? It can be in liquid form, it can be in solid form, it can be in gaseous form. I understand what I'm saying. So there's some gas. If you mix, for example, if you mix sodium, you throw it into the water, it will explode. Because sodium is hyperactive. The same if you take chlorine, you don't care, you are not careful if it will explode because it's hyperactive. So these are things that you can. So if you quickly look for either positive or negative to react with. You understand what I'm saying? So it will give a lot of energy during this reaction. That's what is called enthalpy. I understand what I'm saying. So we will do that later. We study those things, enthalpy and entropy and Born-Haber cycle, all this stuff. So on and on, elements cannot split by just chemical mix. So elements can form molecules, it can form reaction with other to form molecules, whatever the either gaseous state or liquid state or solid state. Are you understanding me?
Yes, sir.
Good. Now, elements can be divided into two. We have metal and non-metal. What I call it?
Metal and non-metal.
For your level now, you say it is true. But there's another one. It's called alkanoid. What I call it?
Alkanoid.
They are neither metallic nor non-metallic. They are in between. What did I say? They are what?
In between.
In between. So, and also I talk about alloy, right? That you combining two or more metals together. For example, this iron that you are using to iron your clothes, it contains two major alloy. You may see copper and what? An iron melted together to form an alloy. You may see tin and iron melted together. That's called an iron alloy. So there are two major issues, but there are three. But for your level, you have metals and what? Non-metals. I told you that the third one, that one is in the middle. I understand what I'm saying?
Yes.
It is neither metal nor non-metal. Let me give an example like this. What you they use in making dye, like this silicon, germanium, all this stuff. They are neither metal and neither non-metal. Indium, so you understand what I'm saying? There's another thing called indium. So it's neither metal nor what? Metal. All these things. So you can't, so that's on this one, you can't put them as part of metal or non-metal. There's a lot of what we're going to do. This. And I like this book. This book it has been long. It's called Outline Chemistry. So they demand deep justice to all these elements. And by God's grace, the testing is still available on our best to go and get to the market. I understand, what I'm saying. Demand deep justice to most of the work we explaining the chemistry. So what I'll bring out? So we have metals like copper. You see, I wrote Cu here, right?
Yes.
What's the meaning of Cu? Most of these elements, when they name these elements, they don't name them with English language. What I said? When they were discovered, most of them they didn't name them with English language. So this Cu means cupru, what I call it, which means copper. It's a Latin word for what? It's a Latin word for what? Copper. So sodium, it is called Na. Why is it called Na? Say natrium. Natrium. Yeah. So the English is called sodium. But the symbol is what Na. They rather go by the Latin name. You know what I'm saying? When we have iron, you see I wrote Fe, right? Say ferrum. Good. So you see I wrote iron. So they didn't use English language. They used the Latin name to denote the same symbol. The next one, non-metal, we have sulfur. How many of you used to bring out sulfur from the bottle? You have to do this. Raise up your hands. Everybody does that. If you eat beans, that gas that came from your farting is called what? Sulfur. That's why you should smell. Did you understand what I'm saying? That's why it's what? It smells. The same thing you see most of this compound in the rotten egg. That's hydrogen sulfide. rotten egg. Rotten egg contains what? Hydrogen sulfide. Why does it contain hydrogen sulfide? So the compound it contains sulfur. I know another thing that was made with sulfur. You see it every day. When you enter bike or you enter your car. Hmm? You have to be an abstract thinker. Think fast. Eh? No, that's carbon dioxide. Carbon monoxide. That's nonsense. Most of all this you see it daily in your daily life, but you don't know what it is. So that's why you come and learn to know what it is. The actual name they call it. Universal. Your tire. I've said this thing before. That tire was made with what? Sulfur. That's why it burns. The burn is different. I understand what I'm saying. So the next one is called hydrogen. You can see I wrote H, right?
Yes.
You see normal H. Hydrogen is hydrogen. Didn't name it Latin. Last one is called chlorine. You see I wrote Cl, right? Good. C and what? Chlorine is what? Chlorine. Good. So these are the metals and the non-metals. What do I call it?
Metals and non-metals.
What do I call it?
Metals and non-metals.
Good. So these are the metals and the non-metals. So we have sulfur, hydrogen, and what? Chlorine. They are non-metals. The next one is copper, sodium, and iron. They are what? Metals. You understand what I'm saying? Then the next one we have what is called symbols. So symbol can be defined as a mix of representing elements using letters. Again,
Symbol can be defined as a mix of representing elements using letters.
again,
Symbol can be defined as a mix of representing elements using letters.
again.
Symbol can be defined as a mix of representing elements using letters.
Good. So in writing the symbol of an element, if the symbol of the element is one letter, e.g. hydrogen, nitrogen, oxygen, potassium, sulfur, it must be written down in capital letter. It must be written down in what?
Capital letter.
So we have H for hydrogen, N for nitrogen, O for oxygen, S for sulfur. Have you seen nitrogen before? Where do you find nitrogen? Okay? Clap for him, please. Nitrogen is a what? Is a what? It's very cold. It's dangerous. So without nitrogen, that means you are eating, you will not be able to eat this. And they use it in fertilizer. Yeah. So if you want the ground to be well fertilized, nitrogen is part of the compound that is used. Are you understanding? So clap for him again. Clap for him. It's a good class. It's a good guy. It can turn someone into a spoon. Just turn to iceberg. And it's because you have been to fish this ingredient. Then they serve a cold room. Eh? Eh? Is that where you learn it? Okay, your chemistry is at what cost? Nitrogen is a very powerful. It's also part of the component we used to breathe in, but it does not react with our system. Are you understanding what I'm saying? Because inside air does not contain only oxygen. They say we breathe in oxygen. No, we don't only breathe in oxygen. We breathe in air. Air is a compound. It contains nitrogen, oxygen, and one particular gas. That's what forms air. Are you understanding me? Yes. But it can be separated anyway. That nitrogen can be separated, that oxygen can be separated. So that is that concerning that. That's good. So the next one, oxygen. Have you seen oxygen before? Oxygen gas. Have you perceived it before? How does it smell? Huh? If you breathe in oxygen, how will your brain be? What do you think I will happen to you? Huh? Clap for him. He just guess, but he get it. What do you say happen? It's refreshing. Fresh. If you breathe in oxygen, you'll be gentle like a lamb. What did I say? You'll be docile. Just be looking. Because it will enter into your brain and refresh your what? I mean real oxygen. And as and the dangerous thing about oxygen is that if you bring fire near it, what is it be happen? Eh? Why is it burning? It's very combustive. You know what I'm saying? So so it help fire to what? To burn. But it's light. And if you breathe in oxygen, real oxygen, you will just be gentle, you will be smiling. It will make your head what? More lighter. So then the next one is sulfur. This one smells. It what?
Smells.
Is one the thing that they call something brimstone. The brimstone. Brimstone is mainly made of what? So that's why it burns tirelessly. That's why they call it fire of air fire. Huh? What makes that fire more dangerous? Because it's made of what? Sulfur, brimstone. And as it's burning, it never stops. Are you understand what I'm saying? It continually burns. That's the danger about it. So the combustion is very powerful. Are you understand what I'm saying? That's why inside the earth core, you see that it's made of iron and some other things, and also brimstone. So inside the earth also what? Burns. That's why the earth rotates every day. It burns. The core of earth crust. Are you understand what I'm saying? That's where fire is. It never stops because it's made of brimstone, and brimstone is made of what? Sulfur. So that is that concerning that. Let's go. Calcium. Where is it? Oxygen and potassium. Let me pray. Where's that happening? Where's the water? The symbol is capital letter Q. What I got it?
Capital letter Q.
Don't forget to write it down. Respectively. The symbol is what? Capital letter what?
K.
K. That's potassium. So HNOSK. That's potassium. So respectively. What when you hear the word respectively, what does it mean?
Another.
Eh?
In order.
In what?
Order.
Okay. Aside from any other words for to denote perspective. In sequence. Clap for him, please. That is one after the words. One after the other. In sequence. I understand what I'm saying? HNOSK. One after the other. The next one we have, if the symbol of the element is two letters, e.g., calcium, magnesium, sodium, and chlorine, the first letter must be written in capital letter, and the second letter must be in small letter. That is, Ca means what? Calcium. Mg means what? Magnesium. Na means what?
Sodium.
Cl means what?
Chlorine.
Respectively, one after the
Order.
So, is there any question before we continue? Before we proceed? Any question? You are free to ask questions. If you don't like to ask questions, you are free to ask questions. Any question? before we continue. Hello, students.
Yes.
Good. Generally, there are four different ways of writing symbols of an element. There are many ways.
Four.
How many ways?
Four.
Good. There are four major ways of writing the symbols of an element. Pay attention to me, please. Look at this. Number one, by using the first letter of the element. What did I say?
By using the first letter of the elements.
What did I say?
By using the first letter of the elements.
Again.
By using the first letter of the elements.
Now look at this charts. These are charts. I wrote the atomic number, the element, and the what, and the symbol. Number one, we have one, hydrogen. What is the symbol? Say capital letter H.
Capital letter H.
Number five, boron.
Bird.
Why are we calling it number five? Atomic number. That's in the periodic table. Boron is what? Good. Number five, boron. Capital letter what?
B.
Number six, carbon. Capital letter what?
C.
Number seven, nitrogen. Capital letter what?
N.
Number eight, oxygen. Capital letter what?
O.
Number nine, fluorine. Capital letter what?
F.
Number 15, phosphorus. Capital letter what?
P.
Number 16, sulfur. Capital letter what?
S.
Number 23, vanadium. Capital letter what?
V.
Number 53, iodine. Capital letter what?
I.
So, by using the first letter and being in the form of what? Capital letter. Yeah, start reading.
Number one, hydrogen, capital letter H.
H.
Number five, boron, capital letter B. Number six, carbon, capital letter C. Number seven, nitrogen, capital letter N. Number eight, oxygen, capital letter O. Number nine, fluorine, capital letter F. Number 15, phosphorus, capital letter P. Number 16, sulfur, capital letter S. Number 23, vanadium, vanadium, capital letter V. Number 53, hydrogen, capital letter I.
Iodine.
Iodine.
Iodine. Good. They say we are confusing phosphorus and potassium. We are confusing phosphorus and potassium. No. The symbol for potassium is what? Capital letter what? K.
K.
Did you write it? Yes? Oh my God. Let me write it again. Number what is potassium? Hello, let people come with our No. This side. Number 19. Right?
Yes, sir.
I'll teach you this secret of just 7. Do you understand what I'm saying? Number 19. That's potassium. That is what? Potassium. Potassium. How many of you have eaten potassium before? You eat it before. What about you? You have eaten potassium before. You know what I mean? What is it in what is it? Yeah, that's called potash. It's going to keep it somewhere. Maybe next class I will do for you guys. Potash. Do you understand what I'm saying? Most of you that usually stick potash and eating. Stop doing that. Stop what?
Doing that.
You can only use potash when you are making the jute leaf, which you might call ewedu. It's called jute leaf. If you are making that leaf, you put the potash in the water. It will act as catalyst to soften the leaf. Are you understand what I'm saying? So don't just eat it raw. It's not good for your health. So we have potassium. So it's number what? 19. capital letter K. The next one, we have by using the first two letters in the name of the element. By doing what?
By
Using the first two letters in the name of the element.
By doing what?
By using the first two letters in the name of the element.
Good. Number one, we have number two, we have helium.
Helium.
He. Say helium.
Helium.
He.
He.
Number three, we have lithium.
Lithium.
Li.
Li.
Number four, we have beryllium.
Beryllium.
Be.
Be.
Number 10, we have neon.
Neon.
Ne.
Ne.
Number 35, we have bromine.
Bromine.
Br.
Br.
How many of you have read something that contains bromine? Call it a bromide. You have to stop eating it. That's not bread. There's some bread that bromate that contains this thing. There is reaction of bromine and some other things. We call it bromate bread. Stop eating bromate bread. How many of you know what this gas is? Where is it from?
It's from
Clap for him, clap for him, clap for him. Clap for him very well. Clap for him again. Yes. Yes. I will promise you something. You know what I'm saying? So remind me. I'll give you. If it's not today, this I will just remind you. As I'll give you a small gift. It will be financial, just small. I'll give it. So it is found in what? Weather balloon. Even all this balloon that that gas, when you blow air into it, the thing they use in making it is that helium. I know what I'm saying. That balloon here, even weather balloon, they use helium to make it. Please put it in the front of your mind. Then the next one is lithium. Where will you find lithium? You use it every day, but don't do that. Lithium. No, nice. Lithium. 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 Finish the statement. Lithium. Lithium battery. That battery in your watch, wristwatch, even computer, is inside this thing, this multimeter. You know what I'm saying? It's called lithium what? Battery. So it's lithium they use in making that kind of battery. Let me show you. I bought this glucose tester. You are not about it now. And this patch. So I've put the lithium battery in there. This is lithium battery. This is what?
Lithium battery.
Look at it very well. Lithium battery. Very tiny but powerful. Do you know what I'm saying? So look at this. Anything you are learning in science is practical. You can practice it in the real life. This is what lithium. What right there?
lithium.
Huh? This is why I remove the battery and put it in here to make it function. So they use this to do blood test, glucose. Small but mighty. That's it. That's right. Are you seeing it? It has what? If I'm not using the gate, it will be off by itself. You can see that's off. So the battery it is using is called what? Lithium battery. I will give you an assignment. Go and do research. Which country has lithium. Where they should, which country is the country that they used to import lithium? Each country has its own minerals. You understand? So like Nigeria now, we have gold. There are some things that we have in Nigeria. Yeah, we have tin at Ajabuta, even in Shaki, we have gold. We have this different this in our states that we have most of all these elements. You understand? And these minerals. So go and do research. Which country is more popular with lithium? There's a particular country that there has a lot of lithium in that country. I know it, but I won't say it. Go and do research by yourself. Go and do find this. You understand what I'm saying? In the next class or markets, go and do your findings. So go and do your findings about that. So next one we have what is called neon.
Yeah.
N-E.
N-E.
Neon.
Neon.
N-E.
N.
Where can you find neon? One of your friends wants to work at neon. Where can you find neon? You see it every day, or you don't know it is neon. Where can you find it? I just give you a clue. One of your friends used to work where this before he left the place, where they used to use neon. So where can you find neon? The guy used to come to church. He wants to work in where you do neon. Where can you find neon? Eh?
Paint.
Paint? Nope. The work that he was first doing before he went for paint. Where can you find neon? Nope. How finding is ceramics? No. No. So where can you find neon? Going, I will say it. They call it neon sign. All those lights that is used in name pharmacy, all those this that is in name hotel, that thing that they use that light. That light you see that they do coil it something like this and use it at the top of pharmacy or some other even hotel. Do you understand what I'm saying? That's called neon lights. Mostly hotel, you see there, right? Or you go to a pharmacy, they put that sign there. That light that they used to design it, they used to write name of name of a particular it may be a company, it may be a this. That light is called neon light. It's different from normal, these are normal lights. So the gas in there is called neon. It's an inert gas. It's an what?
Inert gas.
What does this mean? It does not react. It's different from halogen bulb. It's different from what?
Halogen bulb.
Good. Something you have worked with halogen bulb before. Then we go for crusade, right? Those bright lights that can blind somebody. They are halogen
Bulb.
There's also something called limelight. That's another thing entirely. You understand what I'm saying? But neon light is an inert gas. The gas inside that this thing is neon. All this one now, this one are LED. What do I call it?
LED.
This one they are using this tab and this class. It's LED lights. But neon light, you see it, they use it to write the name of this thing. So they will bend it, they will use to write the name of a particular, maybe pharmacy, hotel, any this thing. They even be bank. They can use that neon light to write it. And it's in different color. Are you understand what I'm saying? It's in different levels. Good. No worry, this I'm sure you understand.
But the one in church, what are we doing?
You want in church? It depends on how it may be light emitting diode or wait a minute. It may be zinc sulfide. Like one that was breaking that thing. That this thing is zinc sulfide. That's why in your life, never try to abuse use some people do it. In some let's say those outside people and this, they will smelling that bulb. They will remove all the bulb and be smelling it and be taking as if it's drug. What they are smelling is actually what? Zinc.
Sulfide.
What they are smelling is actually what?
Zinc sulfide.
Good. And it's very deadly. It will go and destroy their lungs. Don't worry. In this class, I will teach you a lot of harmful substance that you in your life you must abstain from them. You see, make your age mates taking those substances. You need to warn them seriously because at the long run it will damage their internal organ. It what? Lots of people do smell. They suck away their kids. What do you think they are smelling? Sulfur, hydrogen sulfide. It will damage their lungs, destroy their organ. I understand what I'm saying. Never should you in your life be deceived to take those kind of substances. I will teach you so that you know what is what and be able to avoid it and be able to help others to be free from such nonsense. Are you understanding me? So zinc sulfide. You see those are bulb. This there's this long bulb too. That long one that they used to put inside. They call it one. That one to contain zinc what? Sulfide. We used to use it before. It does this. That is a very long this one. So if you ask cartridge and this you on it, it will write. And some place they use it even in bank. But this time around they will put purple this thing as a purple light. So no fake money or original money. You use it in bank. So in your life, don't ever say you want to be smoking those things. They are harmful substance. They are what?
Harmful substance.
It's part of what they supposed to teach you. They are harmful substance. So each thing that we see every day, those elements are there. I understand what I'm saying. Mm-hmm. So the next one is bromine. I've told you, don't eat bread made with what? They call it bromate. Before you eat anything, check that label. Read it. Learn to read. Read. Don't just take anything and just eat anything to your system. I understand what I'm saying. This bread will look sweet. No, read it. If you just see bromate free, don't eat it. If you see bromate as part of the component in it, give them their bread and go away. I understand what I'm saying. There's a lot of organizations that are not going against all these dangerous substances, like NAFDAC. You know what I'm saying? Write it down, NAFDAC. Go and check the full meaning of NAFDAC. So write about them. The person that is the person in charge that later died, the woman that was in charge, Dr. Dora Aquili, do research about her, do research about NAFDAC. The acronym, the meaning, what it means. You know what I'm saying? Yes. So that woman did a great job. I like her, Dr. Dora Aquili. If not, all of us will have died in this nation. But there are some substances, if you eat it, it will damage your kidney, damage your liver, damage your system, damage your blood, cause blood cancer, cause colon cancer. Many people just die. I know what I'm saying? Because of what they want. They eat. They will go to the market, they will take an apple, they will buy apples. That apple is good. They will not check it well. It might be injected. You look at it very well. If you see any slices, don't take it. I understand what I'm saying. Some people just go and buy bromate bread. They eat it. They say it's sweet, it's good. And it's damaging their organs. When we enter biology properly, you understand this thing I'm talking about. Whereas you see how organs function, how a lot of people's organs are damaged because of what they eat. When we enter nutrition, digestive system, this thing, you see all these things. So bromine, don't forget it. Bromine and what? Bromates. Don't forget it. Bromine, Br is number 35 in the periodic table. The next one, aluminium. Again,
Aluminium.
again,
Aluminium.
we have Al. The next one, silicon. Say
Silicon.
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 We have Si. The next one, barium.
Barium.
Say barium.
Barium.
We have Pa. The next one, argon.
Argon.
We have Ar. Say argon.
Argon.
Where is argon used? You've seen it several times, but you don't know. Where is argon used? That olden bulb, that is that yellow light, that's what argon was. Argon bulb. The gas inside there is what?
Argon.
That yellow light. Before we start using white light everything that you all this other this germanium light, all this stuff. That one we are using, that will be very hot. It's called what?
Argon.
And they also use it for incubators. They use for what?
Incubator.
So they use for incubators too. We can make incubators in this lab. Yeah. Without even buying it. We can make it. We just use argon bulb. So it's the heat that the egg will need. Before you know it, every day you just use that argon bulb, that light, in a closed compartment. Before you know it, 21 days, you are going to hatch an egg. Without checking up, we will hatch an egg. Yeah, we will try it in this class. Don't worry. Just like this. That white this thing that you gotta keep. We used to do incubator. We go and look for argon bulb. We pass wire through it, all switch on and off. So we will move for egg, we will close it inside that white this. We do argon bulb. We will just be changing the location. We will not touch it. We use maybe a spoon. Change it. For the next 21 days, it will hatch. It will hatch and egg. Yeah. That's the way you're looking at me. I'm telling the truth. So it's called argon. The next one is called calcium. What I call it?
Calcium.
What I call it?
Calcium.
Good. Ca. So where can you find calcium? Medicine. Then another one. You take it every day. Yeah. The next one. In your milk. You see calcium in your milk. Next one we have xenon. This is also another inert gas. This is another family of neon, argon, xenon. They all belong to the same. You see they end with On, right? On, right? On, aside from silicon. Are you understand what I'm saying? So we have xenon. Xe 54. Xenon. Xe. The last one is called nickel. Where can you find nickel? Nickel, where can you find nickel? You use every day, but you don't know how to use it. Where can you find nickel? Most of all these products that we buy and we use, most of them, all of them, they contain chemical compound. I understand. But you may not know it. It may be electronic this thing, but you may not know it. Look at this one now. This is lead. Look at it. This is what? Lead. We use it to solder. Use what is called soldering lead. So all this that I'm teaching you, there are things you see every day, but you not know that it is what it is. Are you understand what I'm saying?
Yes, sir.
So nickel, you see it in your iron. It's an alloy. they burn maybe iron, maybe 20% iron, 30% nickel, and manganese. They burn it together to form an alloy. So that's why you can use what's called bimetallic strip. The iron will be auto, all of a sudden, just if you cut it off, you let this go a little bit again, the thing will come again, come back to electricity again, start going hot. Once it reach the threshold, it cuts it off. Why is the material behaving like that? It is because it contains alloy of nickel and some other compound, other metal. The copper metal, the manganese, the nickel, the iron. Are you understand what I'm saying?
Yes, sir.
So these are the systems. So I will stop here. If there's any question, please ask your question. In the next class, I will continue from number 3 and number 4. Any question? Any question? You better be asking question. Any question? Any question? Going?
What is aluminum?
For example, now aluminium is what you use in my door now, my window. That window, this is called aluminium. Sometimes they use it also for electricity. That's the aluminium wire. I understand what I'm saying. Like this first gate now. In some area, like first gate, in some area, let me remember some area. Some area, their wire is aluminium wire. So if rain fall, what do you think will happen? Eh? It's not damage. They will have to wait till it get dry before those PSN or Ikeja or whatever you call it on NEPA before they on light for them. Why? So that is why copper wire is there for what?
Aluminum wire.
Aluminium wire. And different from silver wire. Their conductivity is different. You know when we enter electricity, you understand it. Their conductivity is what?
Different.
Is different. So the form of aluminium, when they use aluminium as wire, the rainfall, you have to wait till it what? It dries. So that's why you see this NEPA, not that they are foolish sometimes, no, they are not foolish. You know what they are doing? Offering some people's lights. In some area like Father Yitu, Somolu, all those ladies, they do that too. If the wire is what?
Wet.
Is wet, you have to off the light, allow the sun to this thing, and the wire is dry before they what? They pass electricity to you. Don't forget this. That's aluminium for you. So aluminium can also be used for area antenna. Have you tried that before? They use aluminium in what? Antenna and area. It's a good conductor for radio signal and other stuff. So, is there any question? I'd like to call it a day. So, God be with us. Next class. To sweat. Bye.